welcome to our lesson on translating the graph of f of x equals x to the nth power. X to the nth power are going to be our power functions where x has some number power, and then translations are those things that cause slides to our pictures. So we're going to take a look at a couple of examples of those. All right, so first we'll talk about vertical translations, which are our y direction changes, moving our picture up or down. And what's going to cause those is going to be the numbers added to the outside of our operation. So when we see our x to a power and then we see a number added or subtracted on the outside, that's going to move our picture up or down. If we see a positive, that's going to move it up. And if we see a negative, that's going to move our picture down. Coming down. And sometimes they can be sneaky and even put our power at the end of the expression. So we have to be on the lookout for truly where are the added numbers on the outside of the power. Here we have a function written sort of backwards, 9 plus x to the fourth, but that's still going to move our picture up because it's a number being added. So this one moves up. All right, for horizontal translations, those are our x direction changes, just sliding the graph left or right. This one's going to seem backwards because a minus on the inside is going to actually move the graph to the right, and then a plus is going to move the graph left. So this one here is actually going to move our parent graph 3 units to the right, whereas this bottom one is going to move 8 units to the left. So you just have to remember that outsides are regular, pluses up, minuses down, but insides seem backwards. But it is true, the positive numbers are going to move the graph left and the negative are going to move right. So if you see that you have a number occurring on the inside and the outside of your operation, that's going to mean that your function has both kinds of translations, vertical and horizontal. So let's take a look at these examples and see if we can identify those. So for the first example here, we have x plus 5 cubed minus 2. So that's our parent graph cubic function because of that power of 3 that's been moved left 5 and down 2 according to our numbers inside and outside the parentheses. Second one, we've got a power of 4, which is going to look something like this, maybe a little wider at the bottom, parent graph. And inside we've got a minus 7, so remember that's going to move it to the right, 7 units. And then outside we've got plus 1, so it's up 1 unit. So it's pretty easy once you learn the basic rules of where these occur. All right, thinking about the domains and where these graphs are occurring on the grid, if you think about an even and an odd powered function, even versus odd, remember the even powered functions are going to do the same things on both ends, whereas the odds are doing something different. So let's think about how that affects the domain once we translate these. Even and odd. So let's draw an even, example of an even, and here would be our odd. Okay, we'll label them. We'll know which one's which. The domains, if you can picture these moving around anywhere in space on the grid, they both occur forever in each direction, so it's not going to affect the domain depending on where I translate it. It's still going to be the same. It's going to cover all x values at all times, both of these. Let's think about the range. If I'm dealing with an even, some type of even powered function, remember range is my y values. Where does the graph occur in the y direction? If I move one of these even powered functions up or down, it is going to affect my range because the bottom level, the lowest point that we see, is going to be moved to a different location. So ranges may be changed by these translations, but it wouldn't be changed by a horizontal translation. If I slid it left or right, then I'd still have the same range. What about odd functions? Let's take a look at that one. Let's think about moving something like this, that's our odd, up or down. Now I can see the arrows that continue on forever in both directions, both down and up. If I move this up or down on the grid, it's still going to have the same range because it's still going to occur, it's going to continue on forever in both directions. So you can see that ranges of odd-powered functions are not affected by these translations, the vertical or the horizontal. So we're going to go on forever. So let's practice graphing one of these. We've got f of x equals x minus 1 cubed plus 4. So first of all, we need to recall which type of parent graph we have. We've got the cubic. So let's draw what the parent graph would be in here in sort of a black color. So it's going to look something like that, little snake-like figure. And then knowing our translations now and practicing that, we know that we have a move of 1 unit right and 4 units up. So if we need to graph this, of course I can test some points and get a really accurate picture, but just knowing my translation, I can slide it where it needs to be and get a pretty good general picture. So I'm going to move it 1 unit up, 1 unit right and 4 units up. So 1 right and 4 up. It's going to put the new center somewhere right here. So there's just a general picture of where the new function occurs. So let's suppose that we are looking at a graph and we are looking at a translated graph and we need to write the equation to represent the translations that have occurred. So here we have the blue graph is a cubic parent function. It's located on 0, 0 on the origin. It hasn't been translated at all. And then our new translated function is over here, the orange. And we need to count over and see how much it's been moved. So it looks like it's been moved 3 units to the left. So how will we write that in our equation? We need to remember what represents a left-hand move. I don't see that it's been moved up or down at all, so we won't have to represent a vertical translation. So let's form this. So the parent graph, remember, is y equals x cubed, or f of x equals x cubed. And then remember, inside the parentheses is what helps us denote a horizontal translation. So this is left 3 units. So we're actually going to have plus 3 inside, remember? That moves it left. And then we've moved none up or down, so that's plus 0 units vertically. Now when I simplify this, we don't have to have that plus 0 because we're adding nothing, no amount. So we can simplify to just simply y equals x plus 3 cubed. And this concludes our lesson on translating the graph of f of x equals x to the n.